using those resources through different areas of development of mankind, the age of stone, the age of iron, and so on, the industrial revolution, the technological revolution, but everything was set from scratch. This is what we had. And unless we have a meteorite to impact the planet again, we won't be additional supply of material on this planet. And the second one I would like to share is also something you're probably familiar with, is the reserve. So what is left on the ground based on um, actual consumption rate, which is typically some kind of data which is evolving very fast because we are increasing the consumption because of the growth of population on Earth and because of the technological development. So these values are very fluctuating, but if we can get it back on the screen, here we go, we can see that the range are relatively large. So we are looking at elements with still available between 5 to 50 years, between 50 to 100 years, or between 100 to 1,000 years. What this tells also is that once we want to have extracted most of these materials, we're going to be relying on recycling, which is an important point that someone will probably address in the coming minutes. And also, we maybe have to consider shifting from some elements to some other based on their properties. And then if we go back to this one, no, we won't go. Yes, this one. Okay, excuse me. Then we want to go from the right part of the table to the left part, where we have the most abundant element. Of course, this is depending on the properties, and you know that the properties are periodically distributed in the table, but this is not a chemistry lecture. So just to start the conversation with our esteemed panelists, and then I will pass the microphone to Professor Richard Harrington, Director of the Department of Earth Science at the National History Museum in United Kingdom.
Oh, thank you. Thank you very much. And thanks very much for the invite and opportunity to talk today. Yes, it's an enormous challenge we've set ourselves because our governments have made some amazing and quite correct pledges to decarbonize the way we generate our electricity and the way we move ourselves around the planet. What they failed to recognize, and in 2019, even our own government in the UK failed to recognize that once they'd made that pledge to a 2050 net zero delivery, they'd forgotten that we need technologies to do that. And the metals that we've heard about, some of which many of you probably haven't heard of, and a chemist like yourself will understand, but parts of the periodic table we've not been to before. And whilst I would take, I don't think we are going to run out. We didn't, the Stone Age didn't end because we ran out of stone. Technologies have been very good at finding substitutions, but we're under the cosh here. We have time. Time isn't on our hands. We've pledged to 2050. We've got some big challenges in 2035 about transportation, and we need to find the metals for that in acceptable ways. And one of the things is that we know we're going to have to just not only the critical metals, the metals that are in batteries, but some of the more widely used metals like copper. We're going to have to mine as much copper between now and 2050 than we have mined throughout history. So these are some quite serious challenges. And partly my sort of mantra coming to this is that we, and speaking on behalf of the Natural History Museum, we see a future where people and the planet are going to thrive. And so we do need to introduce these technologies to mitigate climate change. We do need those metals without doubt. And currently, recycling is not enough for those. And with the way that industry is geared up, we're going to need to get those metals out of the ground very quickly. And so we do need mining. We have to accept that. But what we do have is a choice of where those metals should come from. And what we should be looking at is a way where we weigh up the, if you like, the three ways that we measure the performance of a project. And I quote economy, environment, and equity. So there's a social aspect, there's an economic aspect. Obviously, the project needs to make money and do well for the planet, but we also need to make sure our environmental footprint is net positive. And so we can work towards a mining industry that can deliver that. And there are some good models as to how we can do that. So we can recover those metals, we build the right recycling, but we also then make sure that the legacy we leave after mining, because after all, mining is a temporary intervention to recover useful metals. It shouldn't be the only thing we do on that piece of real estate. Too much in the past, we've done our mining in a way it's cradle to grave, and we need to adopt cradle to cradle approach as we do in manufacturing, so that our mining is inherently reconstructive. So thank you. I think I'll leave my comments at that.
Thank you very much. Can I get the slide back, please? Thanks. I'm going to now pass the microphone to Andres Rebeliedo, President of the Latin American Energy Organization. You got already your microphone.
Thank you very much for to have the floor. Sorry, my name is Andres Rebolledo. As the moderator have said that I'm the president of Organización Latinoamericana de Energía, Energy Latin American Organization. It is a intergovernmental organization, and our mission is to support the countries in the energy policy. That means my field in my knowledge is energy, but not so my minery. But any case that here we are talking to mining, critical mining, especially the focus of my intervention. And I would like to share two ideas in this first intervention. Sorry. Uh, First, I would like to stress and remark that if we want to talk about the energy transition, it's not only transformation of the energy sector. We are not talking about only about the transformation of the generation source. We are talking about the miner. I mean, in some way, the first idea I would like to share with you this afternoon and is the miner is part of the energy transformation. It's part of our energy transition, and so that is very important because when politician and when people who is in charge of the public policy to make decision, I have to take into account this perspective because it's work together. uh, And the second idea I think is important to share with you this afternoon as well is given that they represent in some way the voice of Latin America, because our organization represent the energy interest, the official, because our organization is composed by the government, and given that, we are working in this idea, and all the responsibility they have to be in the energy, but also in the miners ministry of public policy, and they have to work together in order to be adequate in this decision. And finally, in this first intervention, to say, which is quite relevant, the last days, the last month in Latin America. I'm talking about here the security and also energy security, not also related to generation, but also the capacity to produce and to put in available the minor and the critical miner. Some way Latin America today is playing a role, different geopolitical role because of our resort, and we have taken into account this situation. Situation.
Thank you very much. Now the microphone for Ladislas Changa, IPCC Vice Chair.
Okay, thank you very much. And I would start by expressing appreciation for being invited to be part of this prestigious panel. And I would start by echoing what you have said. We have limited resources on the planet, and therefore we need to ensure that exploration of raw materials strongly affect the climate system or the component of the climate system, and therefore are contributing to enhancing the or amplifying the changes in the climate. So the exploitation that we are doing, that we are increasingly doing, is contributing to affecting the climate system, and therefore is one of the source of the problem that we are dealing with. And of course, we know that the climate system is characterized by complex feedback mechanism, uh, some of which are very uncertain. So we need to ensure that we use very wisely and sustainably the raw material that we have. And you have highlighted some of the metal and element. They have only 5 to 50 years to get finished. So that means we have problem at the end. So what I would like to call for our consideration is that our use of raw material should be informed by the best available science from IPCC. And also, we need some kind of transformation of mindset and attitude on how we approach the use of existing raw material, uh, trying to accommodate I mean, the nature-based solution in the utility of the raw material. Uh, the mindset of trying to protect the value of humanity and the environment, putting the value of humanity and the environment more in all that we are doing. So I will stop there, and just once again, we need to ensure that our consumption of raw material is informed by the best available science provided by the IPCC uh, every cycle.
Thank you very much. We are collecting these viewpoints, and then at the end of the story, we will go in the discussion part. So I continue to pass the microphone, and this time it's going to be with a little difference from what was announced previously, but now it's going to be Stéphane De Bruyne, Director of External Affairs, to talk for the SQM.
Thank you very much, and thank you also to the organizers for letting us talk on this panel. From my side, I joined SQM in 2005. I was responsible for the sales of lithium and iodine for more than 10 years in Asia Pacific. And sustainability was something remote for me at that time, but must have been somewhere in 2006 or 2007. I landed in Beijing, was winter, was at night, and I got out of the plane, and the air was just dense. I had a sting in my eyes. It tasted bad in my mouth, and I realized that we can actually have a serious impact on our planet. And so, for me, when then very gradually afterwards the electrification of mobility became a possibility, and then became a reality with the emergence of the Tesla Model 3 and the Chinese electric vehicles. Of course, I was very, very motivated on this. Today, I'm responsible for stakeholder engagement, and you see a lot of questions from stakeholders about mining. Is that automatically negative? And in my experience, it is. And so I would like to talk very briefly about that. Um, there's no mining without impact, but if you look at the lithium, for instance, it's a very essential element. Without lithium, you don't have rechargeable batteries today. you don't have electric vehicles, and they have the potential of being recycled. So we're digging stuff out today with the chance of putting it back in the loop, a very solid chance because it's already being recycled today, in 10 or 15 years more. And so there's no mining without impact, but the question is then, how do you define the mining of the future? And so at SQM, we started working on this back in 2016, because the whole discussion was becoming more prominent. And for us, you need to look at sustainable mining in two ways. You need a holistic approach, and you also need a responsible approach. And so we are in a good place. I think Chile has probably the best lithium in the world. I'm biased, of course, but life cycle assessment studies clearly demonstrate it's the lithium with the lowest footprint in the world. Um, we have set as a company ambitious targets. We want to be the most sustainable lithium producer in the world. So our goal is to be carbon neutral by 2030 in the lithium. And last year we decided to go even further than that. And so we have also now made public our innovation roadmap for water neutral lithium. And that is a complex puzzle to solve, but we're going to combine direct lithium extraction with seawater reduction, desalination, reinjection, and I'm missing one, and mechanical evaporation. Um, Last month, we actually invested $20 million in a French company. It's called Adionics, which is one of the leading DLE technology companies in the world. And so you can imagine that we believe very strongly in this technology, and we're working very hard on innovating. We have been innovating since 25 years ago, when our management laid out a plan to quadruple capacity 5 years ago, and to do so while at the same time reducing the brine extraction in absolute numbers and also the water in the salar. I thought, oh my God, this is really, really ambitious. But today, we have an online monitoring system, and so you can track our progress. We are down 23% in our brine extractions, and we are running since 3 years below 50% of our water extraction quota. Um, so what I'm trying to say is that I think mining can be part of the solution. It needs to be local value add. There needs to be value sharing. In Chile, the mining is for lithium at least is done through public-private partnership. So we pay a progressive royalty to the government. Last year, we contributed in total $5 billion. So there is value sharing to the country, to the region, to the local communities. We try to be transparent. I've mentioned that. And I think innovation has such a tremendous potential. And once companies set themselves goals, and then put the engineering teams together towards the target, exceptional things can and are happening. And I think that's an important point to make in this discussion. Thank you.
Thank you very much for sharing your experience and opening the discussion to innovation and the contribution of research and development to the sector. So we have another guest who joined. Would be welcome, Professor Lagos. But for the moment, the microphone will be for Maria Jose Batista, UNEP's extractive hub for UN Secretary and General Initiative on Critical Energy Transition Minerals. So you have two microphones. It's your choice.
Thank you. Yes, I work for the United Nations Environment Program, and I am also involved in a new initiative that has been launched. It's a UN initiative that involves not only UNEP, but any UN agency that is actually dealing with critical minerals in the UN from different perspectives. So, including the regional economic commissions, UNDP, UNIDO, UN Women, different perspectives. There are two challenges when it comes to raw materials and the energy transition that we are pretty concerned about within the UN and trying to focus our attention right now. The first one is the big question: how do we avoid creating a bigger problem than the problem we are trying to solve? That is a key question. And I'll give you some numbers to show that. Yes, we will need to extract way more at a faster pace. And already with the levels of extraction and production we have today, we see, for instance, that um, 50%, for instance, of global copper and lithium production are in areas of high water stress, that 54% of the minerals that we call critical energy transition minerals are on or near land from indigenous peoples. We have also 7% of global deforestation that is indirectly caused by the mineral sector, and it is the largest waste producing sector in the world. So these are impacts that we have to consider will go way up. We need to think about how to minimize them, how to lower the pressures on extraction. There are different ways to do that. The second main challenge we're looking at is how actually can we use this opportunity for mineral rich developing countries to actually harness the economic benefits from this new wave and build and transform their economies basically. So it's not only about protecting the environment, it's also there are people involved, there are livelihoods involved. And you might know that most of these minerals, of what we call the critical energy transition minerals, are actually in developing countries. I'll give you some figures. 70% of cobalt, 47% of copper, and almost half of lithium are in developing countries. They obviously have the right to develop and to use this for their economic transformation. But how to do that? We need to think, and this is where the UN is going to try to come in. These countries will need support on many fronts to build capacities. I'll give you an example. Even the capacity to negotiate good, solid contracts with the mining companies so that they actually get the benefits, capacities in attracting foreign investment, capacities in trade, negotiating good trade agreements or getting benefits from the current ones that they have. They will need to develop also capacities to create the safeguards from an environmental and social point of view, because there are a lot of human rights issues, environmental issues linked to the sector. And finally, they will also need to create a strong regulatory system so that you prevent, you mitigate, you assess these impacts we're talking about. Let me stop here. In the UN, we are trying to help countries build those capacities, but we're also trying to build trust, which is in this space is key. There right now is mistrust between consumer producer countries, mistrust between governments and their local communities, mistrust between even neighbors who will be competing to sell these minerals. So the UN is going to come in, and the Secretary General actually announced this week, no, not this week, but 2 days ago, that he is launching a panel with member states to look at what could be principles on critical energy transition minerals. More to come from the UN on that. Thanks.
Thank you very much for these points where we see that beyond the carbon footprints, we also have to deal with sustainability globally, including social equity in treating this issue. So the microphone is now for Professor Gustavo Lagos, Senior Professor at the Universidad Católica de Chile.
Thank you very much. And I must apologize for my being late. I couldn't find the building. I suppose that's not a very good reason, but anyway. Well, I've been in mining my whole life, and that has been quite long already. By the way, so what I want to tell you is that something that you probably know, and that is that Chile has two of the key metals for combating climate change. And those are copper and lithium. And it has them not in any way. Actually, Chile is the first producer of copper now for the last 30 years. And it also has the largest reserves in the world. And it is the second producer of lithium in the world. It used to be the first, by the way, but it was over, it was passed by Australia. And it also has the largest reserves of lithium in the world. So we have there something quite incredible, you know, because not every country has these two materials for, you know, combating the climate change. Now, going to copper. Copper is actually on mitigation. Chilean copper has done very well because about 73 or 75% of the copper produced in Chile, reminding ourselves that it is the first producer in the world, has already contracted 100% renewable energy. So that makes it its mines be on the two first quartiles of intensity of emissions, the two better quartiles. Now we all know that of course the electricity cannot be delivered as it is contracted, but that's another matter. Okay, the contract is there, and that is benefiting the country. And in the case of lithium, the two companies that produce lithium in Chile have announced that have contracted actually 100% copper, 100% energy for renewable energy. And I have seen lately the efforts to actually adapt, you know, bringing water from the ocean in the case of the two companies. But last week, I was visiting the north of Chile, one of the plants, where they put a thermal evaporator. And both companies have one. Actually, SQM's installation has two. It's double. And this allows to recover close to 1.8 million cubic meters of water. And this is quite a new process. It's only the first one in South America, and I believe there's one in Europe installed. So this tells you a little bit about the efforts and the innovation which is taking place. And this is only a tiny bit. Lithium, you know, both companies have pavilions with a lot of this direct lithium extraction methods being you know, researched. And I'm not sure if they have taken already the decision as to which technology they're going to use, but this is something which will come on possibly at the end of this decade, because there are some questions that must be answered yet, and one of them is the reinjection of the brine into the salt flats. But the mode of the mode of production is going to change in the medium term. So this is interesting. And, you know, the amount of money which is going into innovation in the lithium industry is just astounding. Just astounding. And it's a very, very fluid industry, and many things are happening. And I'm very, very hopeful that in the case of Chile, we will be able to develop not only the two deposits already working in the Salar de Atacama under the two companies which now exploit it, but also other deposits about which I could talk for a long time. It's a very interesting story. It's a very interesting story considering that, you know, um, no fresh water has been uh, taken from indigenous communities. Indigenous communities are not very large. There are about 5,000 people. They're still an important population. And they're located mostly on the east of the salt flat, right? And both companies are working with these indigenous communities. And the same happens in other salars, in other salt flats. So uh, with this, I just want to give you just a short view of what's going on. We have many challenges to overcome because, as you know, the mining industry worldwide is considered to be the most offender of the environment. So obviously, we have a lot of challenges to come. But I think that Chilean mining, copper and lithium, we are, it's not that we're going to be, we are one step ahead of the rest of the world. And I have the hope that we can gather this position and show it to the world, perhaps in the next COP, right? That is my program. And I hope you help me, bring it through. Thank you.
Thank you for this optimistic conclusion of your address. And I'm an optimistic person as well, so I agree on that. Okay, so we had this first round of inputs from all of you. So from what I heard and what I thought also before coming, and as you said, the reputation of the sector is quite bad for various reasons. But at the same time, many other sectors are actually relying on the mining industry to be actually provided with the adequate materials they need to their development, and at the end of the story, to be delivered to consumers. So my question, which is a question for any of you who would like to grab it in the air, is how do you see and how do you use in your industry the use of the life cycle assessment for this particular activity, and how to connect that with the users, the other industries that are using these materials. So how does it work? Do you think it's satisfying at the moment? So maybe you want to start. I saw you actually.
Happy to start. Thank you. I just want to make one quick comment to the previous two speakers. So I think it's a fantastic initiative to look at critical minerals and define mining standards and regulation and capacity building. However, why do we limit it to critical minerals? Oil and gas is also mining. And if you look at the volume, um, this was calculated recently by the Energy Transitions Commission. So um, if we take the cumulative volume of all the energy transitions, minerals and metals, including steel, until the middle of the century, 2050, that is smaller than 1 year of coal mining, because 1 year of coal mining is more than 8 billion ton. So I think we should be broader in the approach, and I just wanted to mention that specifically on life cycle assessment. So we are working with life cycle assessment since 2018. You cannot manage what you don't measure. So if you want to be carbon neutral, you need to identify and you need to continue updating and identifying that. Concretely for SQM, we know for lithium carbonate, about 60% of our carbon footprint is coming from the soda ash input. And so we are working internally. This is one of our innovation projects to actually produce our own soda ash and reduce that footprint to become carbon neutral. So I think life cycle assessment, it's a lot of work. It's important to do. It's not the holy Bible neither, because if you talk about life cycle assessment to the local communities who have a totally different cosmovision, they will disagree with the concept, because you're measuring harm to Pachamama, which they prefer not to do. So it's not everything, but I think as a company, it's very, very important. And on communicating that to the customers and hopefully the final customers. So we are part of the Global Battery Alliance that's working on emission calculation standards and a battery passport. We have also partnered with Circular, who is a blockchain initiative. And so transparency is very, very important. And the more transparency we can give to the interested stakeholders, it's a better mining.
Yeah, thank you very much. One of the big challenges we have is that one of the I talked about these three. There's economy, there's environment, and then there's equity. And one of the big challenges has been, how do we measure things like the biodiversity impacts? And we lack, CO2 we can measure, so people carbon, the performance of a project and its carbon dioxide production can be measured, and we need something similar really on the environment to talk about how we are impacting on biodiversity. And that's something that my institution, Natural History Museum, has been working on, is can we do that? And there's a metrics of looking at the intactness of biodiversity. So what should it have been like before human actually intervened? And this is quite a useful scheme, but something like that industry can use is really essential, because you're right, life cycle analysis of the projects, but also what's it doing for the environment. And actually what we'll see is that some places like Europe, where we've had mining historically and we've disturbed our own environments, actually bringing mining back, you can design projects that are very nature positive. So actually, this could encourage us to seek metals closer to home. The waste dumps that are sitting in Europe, old mining districts under our noses. In Cornwall, we're seeing a resurgence of mining focused on lithium, going back into an area that was mined for previous minerals. And actually, in the process, you can then make that legacy better. So I think absolutely we need to have some better drivers of analysis of how our projects are doing. On the social side, I can't comment, but obviously there we need to have ways of how do you monitor the social impact versus on one project versus social impacts of another.
Thank you very much. Yes, Professor, maybe then any order of appearance or on this specific point? Okay.
Yeah, in UNEP, we look at two approaches. We do use the life cycle approach to look at the potential, to assess the potential impacts of the mineral sector. But we also look at the mineral value chain to look at not only the impacts across the sector beyond the mine, but also the opportunities. What we were talking about just now about equity, the elements of where can we help countries become more than just a commodity exporter? How can they add value? How can they go into other parts of that value chain? But we also use the value chain approach to look at um, the bottlenecks, the problems. I'll give you an example. In the mineral value chain, you have uh, lack transparency in at the commodity side, so you don't really know how prices are determined. They fluctuate. There's some transparency issues that need to be dealt. That's one example of things you can look at and focus using the minerals value chain as well as the complemented with the life cycle assessment. Is there? There's a microphone.
Yeah, so I think I will just have a small contribution regarding this discussion. we know that there is a difference between global north and global south in terms of the technology and the capacity, even in exploration. So one problem in one part of the world will have implication in entire climate system and entire globe. So what I would is like to see or suggest is to enhance or strengthen the sharing of knowledge and the technology in mining exploration to ensure effectiveness in mining. Yeah.
Thank you.
Yes, thank you very much. Yes, I would like to ask a specific comment about the previous intervention and specifically regarding the point that the possibility to uh, this part of the history where Latin America as a developing region has the opportunity to play a role, different role in the global economy because of the resources that we have. I think there's a debate, there's a debate in Latin America regarding the possibility to make some level of industrialization, to add value to the global chain, to the regional chain, in taking into consideration the resource that we have, especially in copper and lithium, but also the nickel and cobalt. And it's not easy because the economic structure quite different among our countries. But there is an initiative that some government are working in order to move forward and try to find specific initiatives where we can go to work together in the country of Latin America.
Thank you.
Thank you. I just wanted to address your initial question about LCA. Now, we've recently measured the carbon emissions of both SQM and Albemarle in the Salar de Atacama. And in fact, what we found is that SQM has the lowest um, carbon emission per ton of lithium carbonate produced in the world. No question about it. And secondly, is a little bit higher is the Albemarle. And then comes all the rest of the salt flats in Argentina and Chile. And then much higher because the emissions are about 4,000 kilos per ton of LCE of lithium carbonate um, for uh, for the Salar de Atacama, it's the lowest in the world. If we go to the salt flats in Argentina, it's about 6,000. No lower than 6,000, 7,000, and 8,000 in some of the salars in Chile. And then we go to the spodumene production, and this goes up to more than 10,000 tons per. So it's quite a difference. And if we consider lepidolite, which is being developed now by the Chinese, that goes even further up, right? But this, regarding the value chain, it's interesting that there is some indication of there's some correspondence between the emissions of carbon and the value chain. The costs of exploiting lithium from these different deposits goes up in cost as it goes up as well in carbon emissions. That's the first thing I want to say. The second thing is there's much to be done in the measurement of the carbon emission. I happen to be in the panel now of the International Lithium Association, elaborating the guideline that is going to regulate, or at least give a guideline to the companies as to how to calculate this this quantity. And Latin America has about 50% of the world copper production. a little bit more perhaps now, including Mexico, of course, including Mexico and Brazil, and especially Peru and Chile, right? And lithium, it's interesting because it has Chile, of course, as you know, Argentina, very importantly, um, and Argentina may overpass Chile in production for matters which I'm not going to go into discussion. There's no time um, to do that. And Bolivia, which really has developed very little of its lithium potential. But also the incoming player is Brazil. Brazil is coming up very, very fast, but with a Spodiman, not with Ryan's. And that's very interesting, you know. So there's a lot of dynamics in this industry in Latin America, and we should adopt, I think, a perspective from Latin America. So I think we can provide some interesting things, continuing to be optimistic.
Well, thank you very much. I think we are almost reaching the end of this session. So I would like to thank all panelists for sharing your views, your feelings, and your experience about that. Of course, for such a large and important topic, I will not propose a conclusion as a moderator, but just to mention, if I wrap up everything of what I heard, beyond the direct carbon footprint, I have heard also the waste management aspect of things by this example of re-injecting brine in the system. I heard also some social vision of the owner of the land and having also developing countries into the play. I also heard about what you mentioned, Stephen, about a holistic approach to the problem, and that's very important. And I think that actually drive us to looking at a sustainable approach, encompassing all these aspects from social point of view, social impact, equity, carbon footprint, waste management, safety. We didn't talk a lot about safety, but safety of materials and processes also are very important. And it's going to be maybe for another panel organized by our friend at the Mary Foundation and Cortes Solari. So I would like to thank you again and thank the audience.
And what you didn't mention was biodiversity, of course, but you meant to, didn't you?
Yes. Yeah. Thank you for reminding me that I was meaning to say it. Okay, maybe we have a photograph to take. Okay, thank you very much.